maximum XOR after operations. So for this problem, we are giving an array nums. So for each number, we can do such kind of formula. It's going to be nums I and nums I XOR X. So add and or XOR are just the bitwise operations. So first of all, let's just analyze the nums I XOR X. So what's going to be the final answer? And this X can be any value. So for example, if we have a nums I, let's say, yeah, so what kind of example I'm gonna use? Let me try. So if we have a, yeah, so let me just delete all those areas. So if we have a number, so for example 1 0, this is our maybe the first number, it is a 3, it is 1 1. Yeah, and num I XOR X. So what's going to be the possible result for this this 1 1? It can have 4 different results. Yeah, so if we use 1 1 XOR 0 0, so what's going to be the result by XOR operation? Yeah, so it's going to be 1 1. What about 0 1? So if it is 0 1, it's going to be 1 0. Yeah. 1 0. So what about 1 0? So by XOR operation, it's going to be 0 1. So what about 1 1? 1 1 XOR 1 1. So definitely it's going to be yeah, it's going to be something like 0 0. Yeah, so definitely we can produce all those different kind of numbers. Yeah. So if this number is too big, so for example, because this is X, right, we can use 1 1 1. So what is going to be the final answer? Yeah, it's going to be something like 1 0 0. But this 1 is not necessary, because definitely we're going to add this number. This number is nums I. If nums I is 3, definitely we're going to add this number. So this one doesn't matter. So we will not consider that. Yeah, so we should understand that. So this means by using nums I XOR X operation, so definitely we can get all the numbers. If the set bit, if the yeah, so for example, if the length of the nums I, the binary bit length of the nums I is it's going to be 2 to the power of n minus 1. So that's going to be all the possible. Yeah, so from here, this is going to be all the possible numbers. So if the binary string length is 2 to the power of 2 minus 1, so it's going to be 3. So definitely we have 0, 1, 2, 3. Yeah, it's going to be all the different cases. And now by this number, we're going to use the nums I and this number. So if the nums I is x, this x add this number. So can this number bigger than x? It cannot. It must be less than or equal to x. So for example, if our x is 3, yeah, by using the add operation, definitely we're gonna make the number smaller. So for example, 1 1, maybe yeah, maybe by using the add operation we can make it 1 0. This is possible, but is that possible to make the number from 1 0 to 1 1? Definitely it is not possible, because by using the add operation we can make this 1 0. We cannot make this number 1 0 to 1 1. Definitely it is not possible. Yeah. Now we're gonna analyze all the numbers together. Yeah. So we're gonna check the beta one by one. Yeah. So this can be some numbers. Let me just give a random example. It's gonna be like this. This is one of the numbers. Yeah. But for this beta, this is beta 1. Can we make this beta 1 to 0? Yes, we can, because as I explained earlier, we can always make the numbers smaller from 1 to 0. It is okay. But can we make this 0 to 1? Yeah, so this is a 0. Can we make a 0 to 1? Yes, we can. Maybe some numbers there is a 1, and then we can make the final bit of the of this bit to 1. But if all the bit is 0 here, yeah. So this is another example. So this is 1 1, okay, but this one can also be 0 because we're gonna use the add operation with all those possible cases. So we can always set a bit 1 to 0, but we can never set a bit 0 to 1. So if we understand this, definitely we've already solved the problem. Yeah. So for all those numbers, if the bit from here it is 0, so the final one is 0. If there is 1, so it's going to be 1. So here we have a 1, it's going to be 1. Here we have a 1, it's going to be 1. But here always 0, it's going to be 0 and 0. So this means by using the bitwise OR operation, we've already solved the final. We've already solved the final problem. Yeah. So let's just return, and we're going to use the reduce and OR operation with nums. Yeah, because in Python, this OR can be Boolean OR operations. So instead of distinguish with Boolean OR operations, if it is bitwise OR operations, instead of using this one, definitely it didn't work. So we have to use this OR variable to represent the OR operation, bitwise OR operation for all the nums. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast, and the time complexity is n log n. Yeah, if we use a bitwise operation, it is for two numbers it is log n. So the time complexity is gonna be n log n. Yeah, I think that's all about it. Thanks for watching. See you next time.